Space Concordia Robotics is proud to present our rover for the URC 2022 competition. The rover is designed primarily to be easily configured to best suit the requirements for each of the 4 missions. We are able to operate the rover from a computer and PS4 controller using the 900 MHz band with 2 Ubiquiti radios, a dual polarity Yagi antenna, and 2 Omni antennas on the rover. This allows us to operate the rover in non-line of sight conditions up to 1.5 kilometers from the base station. We have continued to focus on further optimizing the electronic system for ease of maintenance and troubleshooting, as this has proven to be the main cause of delays. The batteries are mounted outside the electronics bay to eliminate the need to open it outside of maintenance and troubleshooting. This reduces the time required to power on or store the rover. The base of the arm rotates with a slip ring to eliminate the risk of a wire getting caught or tangled. We plan to also pass the wire leading to the arm camera through this so we can truly have continuous 360-degree rotation. The operator makes use of 3 cameras for visual feedback during operation. One is on the mast with pan and tilt functionality for an overview of the rover and its surroundings. Another is mounted on the arm to provide visual feedback when interacting with objects, and the third is on the front of the rover for a clear view of the terrain in front while driving. The mobile platform uses the 3-bogie suspension, with the front 2 bogies pivoting on 4-bar linkages for better performance over harsh terrain. The rover has a 5R robotic arm with a gripper and effector to interact with its surroundings. The team has been working on developing closed-loop joint control along with inverse kinematics for more precise and intuitive control. The rover is designed to lift loads up to 5 kilograms in a worst-case scenario. The gripper uses compliant digits to better grip objects with a regular shape. The front 2 bogies have 2 stoppers to prevent the rover from flipping forward when gripping heavy objects. The digits can be replaced with scoops to pick up and deposit loose soil into our custom Raman spectrometer's payload. The Raman spec uses a CCD to record the resulting wavelength of a 532 nanometer laser after passing through a cuvette with the soil sample and buffer solution mixed in. This, in combination with mirrors, filters, and a diffraction grating, is used to detect signs of life in the sample. For non-invasive testing of the rock samples, we use an off-the-shelf near-infrared spec mounted on the wrist of the arm. Currently, the rover is capable of reading and displaying the readings from our 3D LiDAR, allowing us to map surrounding environments. SLAM is implemented in simulation on the Husky rover using the 3D LiDAR for mapping and the odometry from the simulated rover for localization. We use a GPS sensor from SparkFun to obtain our global position within 3 meters of accuracy. The autonomy system will make use of AR tags spotted in camera feeds in order to be able to locate and identify goals.